I have a final exam tomorrow, but my eyes are already starting to close. And now they're getting red due to my constant efforts to keep them open. And by the time the test is started, far from being able to concentrate, I am fast asleep. What is happening to me? So why can't I have full control over my own sleep? It turns out it's because my body has a clock in it and it follows its own schedule. Well, who makes this schedule? The 2017 Nobel Prize winners in physiology, Jeffrey C. Hall, Michael Rosbash, and Michael W. Young, first recognized that the period gene and cryptochrome gene made this schedule. These genes tell us when to wake up and when to go to bed. Where is this clock anyway? Well, it's in my brain. The suprachiasmatic nucleus, or SCN, in the hypothalamus is the clock, the master clock. How can it be a clock? By nature, a clock must return to its starting point in regular intervals. Now let's take a look into the cell of the SCN. The BMAL1 clock transcription factor promotes the period and cryptochrome genes to produce the purr and cry proteins in the cytoplasm. The purr and cry proteins join, enter the nucleus, and meet the BMAL1 clock transcription factor, stopping their own production and decreasing the amount of purr and cry protein in the cytoplasm, thus returning to their starting point. Over time, the purr-cry protein in the nucleus degrades itself, and the BMAL1 clock transcription factor resumes promoting the period and cryptochrome genes to produce the purr and cry proteins in the cytoplasm. This process repeats at regular intervals. This is the way in which the SCN is the clock. It's the molecular mechanism that controls my circadian rhythm. Now think, what do good clocks have? Well, they have alarms. Likewise, the SCN also has an alarm, the pineal gland producing melatonin controlled by the SCN. As dusk sets in, natural light strikes the retinal ganglion cells, which transmits the impulse through the retinohypothalamic tract to the SCN, and then through fibers to the superior cervical ganglia, and finally through the postganglionic fibers to the pineal gland, triggering melatonin production and inducing sleep. This is how the alarm tells me it's time to sleep. Bright light suppresses melatonin production. Now it's time to wake up. The SCN controls melatonin's rhythm by producing melatonin receptors 1 and 2. Melatonin levels begin rising at around sunset and peak around 3 to 5 a.m. and decrease until the next evening. Let's bring this concept back home. What exactly happened to me? To put it simply, I waged war against my own clock as the alarm released melatonin. I broke my biological rhythm, so my alarm rang at the wrong time. During the test. Next time you have that final exam, don't procrastinate the